Dames en here, die akademiese prosesie sal binnekort inbeweeg. U word versoek om asseblief op te staan.
Bomma le bontate, molokoloko wa diruteri o tla tsena mo nakong e kopana. Le kgopelwa ho ema. Ladies and gentlemen, the academic procession will enter shortly. You're kindly requested to stand.
By the power vested in me, I hereby constitute this assembly as a legal congregation of the University of Pretoria. During this assembly, degrees with all the associated rights and privileges will be conferred on the candidates whose names appear in the program. Please take your seats. Ladies and gentlemen, we request you to join us in silent prayer or meditation to give thanks for the achievement of our students. Thank you. Ladies and gentlemen, as Vice-Chancellor and Principal of the University of Pretoria, I extend a hearty word of welcome to you at this graduation ceremony. I would like to welcome the Dean of the Faculty of Engineering, Built Environment and Information Technology, Professor Steyn, the Deputy Dean for Teaching and Learning of the faculty, Professor van der Merwe, the Deputy Director, Student System, Mr. Swanepoel, chairpersons of schools, heads of departments, directors, emeriti and honorary professors, and other lecturers and their spouses, representative of the Student Representative Council, who will present the SRC, Taryn Kriel, Ms. Taryn Kriel, all persons on whom degrees will be conferred this morning, all spouses, parents, and other parties, as well as dignitaries of whom we may not be aware. So I just want to emphasize the welcome this morning to all of you to celebrate this wonderful, life-changing moment, which is what graduations is all about. And this morning, we will be awarding 12 PhDs. They're sitting right here in front, looking fantastically dressed in their red gowns. 96 honors, 23 masters, and 249 bachelors of engineering degrees during the ceremony. And they would come from 4 of the 7 disciplines in the School of Engineering, which is the largest school in the Faculty of Engineering, Built Environment and Information Technology. The total number of graduates from the School of Engineering during this graduation process, or autumn graduation, not only today, is an outstanding number of 578 engineers, which is fantastic. Today's disciplines are chemical engineering, material science and metallurgical engineering, mechanical and aeronautical engineering, and mining engineering. I say it with great pride and confidence that the future for every one of you is extremely bright. The School of Engineering is in the top 1% worldwide. Your qualifications are accredited by the respective professional boards, and they are internationally recognized. So if we look at ranking, which is not the only indicator that we look at, but it's a very important indicator, the school does extremely well. And I'll just cite a few of these. So the University of Pretoria is in the top 50 universities worldwide in mineral and mining engineering, according to the QS rankings by subject. We are the first in South Africa in mechanical and aeronautical engineering, second in mineral and mining engineering, and third in computer science and information systems. That is also according to the QS rankings by subject. University of Pretoria's International Research Network in Engineering and Technology is ranked in the top 50 globally, and the first in Africa and South Africa. And that reflects the UP's engineering school's deep collaborations globally, and also the impact that it has globally. In the Times Higher Education subject rankings, architecture and electrical and electronic engineering at the University of Pretoria are ranked number 1 in South Africa. In the EduRank subject rankings, artificial intelligence at the University of Pretoria is ranked number 1 in South Africa and number 2 on the continent. So technological innovation and its management and application are essential for the creation of prosperity in any country. And the School of Engineering here at the University of Pretoria gives students the best education to make a considerable contribution in South Africa and internationally through advanced understanding of their fields. South Africa and the world want our graduates, not only in academia, but in business, in industry, the private sector, the public sector, and also very important, the non-governmental sectors. So although we hope to retain as many of our graduates in South Africa, we know our graduates are sought after globally. And if you do attract a global position, it's good to get that experience. But I would like you to come back and plow that experience back into our country and onto our continent. And this is a testament also of the quality of our students, but also the quality of our staff. The fact that you are snapped up, many receiving offers before you even graduate, is a testament of the school's reputation and the non-negotiable level of quality here quality of education here at the University of Pretoria. So the Dean, Professor Steyn, and the staff want you to succeed at the highest level and to have the liberty to choose your career trajectory in South Africa or any part of the world. The School of Engineering is constantly striving to reach further and higher, to keep ahead and make sure that the curricula and the research chairs, institutes, centers, research centers have direct contact with the industry to remain relevant and innovative in the current and in the future world of work, and to be in a position to proactively help find solutions for the problems or challenges facing communities and our society. I would say that South Africa needs many more engineers. The number of engineers in our country is in the order of 32.1 for every 100,000 of the population. We are well below the global average, and there are opportunities for many professionals here. We also have considerable talent at the matric level, and the School of Engineering and the faculty get far more applications that they can handle. However, the numbers we can admit are determined by our staff capacity and our infrastructure, or engineering speak, our plant availability, and the budget we get, obviously, from our Department of Higher Education. I'm sure that all of you would have been with us since the first year can still clearly remember the excitement of finding out you had been accepted to study here at the University of Pretoria. And today, many of you will be saying goodbye as you head into the world. But a number will also stay with us to pursue your postgraduate and academic goals. I certainly would believe that we don't like, as UP, we don't like goodbyes. But what is encouraging is that we will see hopefully many of you again. So many of our graduates come back to do short courses in programs that the School of Engineering and the Faculty of Engineering, the Built Environment and Information Technology offer through enterprises. They are very popular and contribute to the necessary path of lifelong learning, which is something that I would like you to take up. In your profession, in the world of work, changes happen very rapidly, and you need to make sure that you continuously learn to be able to adapt and to keep abreast of developments in your particular area. Whichever path you choose, we encourage you to never stop reading, to never stop researching, always observing, experimenting, innovating, and learning from what you see around you. Be inquisitive. Try new things that you haven't done before. The world is constantly changing, and it's up to each one of us to continuously learn and to continuously grow. So on behalf of the whole University of Pretoria community, I wish you happiness, success, courage, and compassion to make today matter, to make every day matter for yourself, but also for the people who do not have the advantages of your education. An invitation is to come and visit us. You will always be part of the University of Pretoria family. Help us grow, draw on the networks you create to contribute to the University of Pretoria, so that each successive generation of students here can benefit from this life-changing education. Congratulations to all of you. We are exceptionally proud of you. Thank you. I now request the Dean to introduce to me the candidates present whose names appear in the program.
Mr. Vice-Chancellor and Principal, the supervisors will now introduce the doctoral candidates.
Mr. Vice-Chancellor and Principal, I introduce to you Louise Jones, who has complied with the requirements for the degree Doctor of Philosophy, specialization in chemical engineering with a thesis titled The Effect of Layered Double Hydroxides on the Vulcanization and Properties of Elastomer Compounds, prepared under my supervision, as well as Prof. Sven Wiesner as co-supervisor. In her thesis, the candidate explored the potential of reducing harmful zinc oxide levels in car tires by using layered double hydroxides as vulcanization agents in the place of zinc oxide. Various types of benign calcium-based layered double hydroxides synthesized and tested in natural rubber and SSBR. The efficiency of the layered double hydroxides was assessed by examining the curing rate and the mechanical properties of the elastomer compounds after curing. While previous studies have investigated the effect of magnesium-based layered double hydroxides, this is the first study to examine the impact of calcium-based trimetal layered double hydroxides. It was found that replacing zinc oxide with a calcium-based layered double hydroxide containing a small amount of zinc, equivalent to up to a 54-fold reduction in zinc concentration, resulted in mechanical properties similar to those achieved with the traditional zinc oxide vulcanization systems. This demonstrates that it's possible to reduce the environmental impact of the vulcanization system significantly. Mr. Vice-Chancellor and Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate.
Mr. Vice-Chancellor and Principal, I introduce to you Hilda Dina Kiumuhimbu, who has complied with the requirements for the degree Doctor of Philosophy specializing in chemical engineering with a thesis titled Lacase Immobilized on Metal Polymer Composites for Wastewater Treatment and Sensing Applications, prepared under my supervision as well as Professor Usisipu Fellini as co-supervisor. In this thesis, Lacase Immobilized on Metal Polymer Composites for Wastewater Treatment and Sensing Applications, the candidate investigated innovative strategies to enhance enzyme stability and reusability for wastewater remediation. With the increasing demand for sustainable water treatment solutions, enzyme-based technologies offer promising alternatives for addressing industrial effluent challenges. This study focused on immobilizing lacase on metal polymer composite beads, incorporating zinc oxide and silver-doped zinc oxide nanoparticles embedded in chitosan and polyvinyl polypyrrolidone polymers. The immobilized enzyme efficiently removed dyes and antibiotics from industrial wastewater under batch and continuous flow conditions. Subsequently, pollutant mineralization was achieved through a phycoremediation step using fungi. Additionally, the research explored the application of lacase in developing a highly sensitive biosensor for monitoring citramonium bromide in tap water and wastewater. This work contributes to environmental remediation, pharmaceuticals, and biosensing, offering valuable insights into sustainable biotechnological applications. This study resulted in multiple peer-reviewed publications and conference presentations, highlighting its impact on the advancement of enzyme technology and biotechnology. Mr. Vice-Chancellor and Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate.
Mr. Vice-Chancellor and Principal, I introduce to you Boitomeo Francina Mashangwani, who has complied with the requirements for the degree Doctor of Philosophy, specializing in chemical engineering, with a thesis titled Biosorption of Platinum 4, Palladium 2, and Gold 3 by genetically engineered peptides for extraction of inorganics expressed on the surface of Saccharomyces cerevisiae ABY100 cells. This was prepared under my supervision, as well as Professor Brink as co-supervisor. In this thesis, biosorption of platinum, palladium, and gold by genetically engineered peptides for extraction of inorganics expressed on the surfaces of Cerevisiae, Saccharomyces cerevisiae ABY100 cells, the candidate investigated a novel method for recovering platinum, palladium, and gold from aqueous solutions. The candidate introduced genetically engineered Saccharomyces cerevisiae cells that expressed metal-binding peptides for batch reactor applications. The study examined the influence of pH, initial metal concentration, and contact time on the biosorption process within the reactor framework. Isotherm and kinetic models were applied to elucidate the biosorption mechanisms for palladium, platinum, palladium, and gold by the engineered cells. These results contribute to advancement in biosorption technology while emphasizing the significance of microbial engineering in solving environmental and industrial issues, thereby promoting eco-innovation and circular economy initiatives. The study's findings were published in journals and showcased at international conferences. This project was conducted in partnership with the Royal Bafokeng Platinum Rasmon Mine. Mr. Vice-Chancellor and Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate.
Well done. Mr. Vice-Chancellor and Principal, I introduce to you Katachelu Lilith Muedi, who has complied with the requirements for the degree Doctor of Philosophy specializing in chemical engineering with a thesis titled Valorization of Acid Mine Drainage, Recovery of Valuable Minerals and Their Application for Wastewater Remediation, prepared under my supervision as well as Dr. Masindi as co-supervisor. In this thesis, titled Valorization of Acid Mine Drainage, Recovery of Valuable Minerals and Their Application for Wastewater Remediation, the candidate explored an innovative approach to tackling water quality challenges, particularly in the Global South. As a water-scarce country, South Africa faces increasing pressure to manage limited water resources effectively. This issue is exacerbated by anthropogenic activities that contaminate water supplies, including pollutants such as arsenic, hexavalent chromium, Congo red dye, phosphates, nitrates, sulfates, and ammonia. The study aimed to recover valuable minerals, primarily iron and aluminium, from bio-recalcitrant toxic acid mine drainage and utilize these minerals in synthesizing adsorbents capable of effectively removing these pollutants from wastewater. This research resulted in 4 peer-reviewed journal articles, 2 conference presentations, and 1 book chapter published in a DHET accredited publication. Mr. Vice-Chancellor and Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate.
Mr. Vice Chancellor and Principal, I introduce to you Lehlohonolo Shane Tavana, who has complied with the requirements for the degree Doctor of Philosophy, specializing in chemical engineering, with the thesis titled Application of Layered Double Hydroxides in Advanced Wastewater Remediation Processes for the Removal of Phenol Effervescence and Nevirapine, prepared under my supervision. In this thesis, the candidate tackled the pressing global challenge of water contamination by targeting persistent organic pollutants, including antiretroviral drugs like effervescence and nevirapine. The candidate developed and characterized innovative photocatalysts and adsorbents based on modified layered double hydroxides, achieving remarkable degradation efficiencies up to 100%. The study advanced the understanding of visible light-driven photocatalysis by synthesizing silver-silver bromide LDH composites that synergistically combine the durability of LDH with the superior light absorption of silver and silver bromide. Using response surface modeling, the candidate optimized process variables such as pH, photocatalyst loading, and pollutant concentration. The research also explored continuous flow systems and adsorption processes, contributing novel insights into hybrid remediation strategies. The findings from this work have been disseminated through impactful publications and conferences. Mr. Vice Chancellor and Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate.
Mr. Vice Chancellor and Principal, Mr. Vice Chancellor and Principal, I introduce to you Intisikelelo Yaleso, who has complied with the requirement for the degree of Doctor of Philosophy, specializing in chemical engineering, with a thesis titled Application of Machine Learning and Knowledge-Based Systems to Support Decision-Making on Fate and Behavior of Engineered Nanoparticles in Aqueous Environment. In this thesis, the candidate examined and supervised various models of machine learning and knowledge-based systems for initial screening and monitoring of engineered nanoparticles behavior, exposure, and risk assessment. The resulting novel hybrid approaches provide scalable and adaptable frameworks, reducing reliance on costly and time-consuming experimental testing. The developed models facilitate nanosafety evaluations and offer a foundation to promote sustainable advancement in nanotechnology while ensuring long-term environmental protection. The results from this study have been published in high-impact factor journals and presented at conferences. In addition, the work was selected by the Water Research Commission of South Africa as the best innovative study in this field. Mr. Vice Chancellor and Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate.
Mr. Vice Chancellor and Principal, I introduce you Victor Amoefi Adubaji, who has complied with the requirement for the degree of Doctor of Philosophy, specializing in mechanical engineering, with a thesis title, Experimental Investigation of Magnetic Hybrid Nanofluids for Enhancing Heat Transfer in Forced Convection Internal Flow Through Transition and Turbulent Regime, prepared under my supervision and as well as Professor Yusha Meyer as a co-supervisor. In this thesis, experimental investigation of magnetic hybrid nanofluids for enhancing heat transfer in forced convection internal flow through transition and turbulent regime, the candidate investigated advanced thermal management techniques to improve energy efficiency in heat transfer systems. The research focused on magnetic hybrid nanofluids, analyzes their performance in transition and turbulent flow regime to optimize convective heat transfer. The candidate addressed significant challenges in forced convection heat transfer by evaluating critical parameters such as thermal performance factors, entropy generation, and nanoparticle hybridization ratio. This work aligns with the United Nations Sustainable Development Goals, SDGs, particularly SDG 7, Affordable and Clean Energy, and SDG 9, Industry, Innovation, and Infrastructure, by promoting sustainable and energy-efficient technologies. The findings published in 4 high-impact factor journals contribute novel insight to mechanical engineering advancing sustainable solutions for energy-efficient thermal systems. Mr. Vice Chancellor and Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate.
Mr. Vice-Chancellor and Principal, I introduce to you Janine Squirmby, who has complied with the requirements for the degree Doctor of Philosophy, specializing in mechanical engineering, with a thesis titled Investigating Aerodynamic Factors in Wind-Driven Grey-Headed Albatross Crash Landings, prepared under my supervision, as well as Prof. Ken Craig as co-supervisor. In this thesis, the candidate explored the impact of wind on the mortality of adult grey-headed albatrosses near a crucial nesting site by combining field observations, weather data, and computational fluid dynamics. The candidate developed a novel method to extract geometric information from an albatross wing, which was used in a detailed aerodynamic modeling across a wide range of environmental conditions. This study links the dominant westerly wind conditions to fatal crash landings in an adult grey-headed albatross and found that stronger northerly winds increasingly hinder feeding and chick rearing, potentially threatening the survival of the species. This groundbreaking study represents the first cross-disciplinary investigation into wind-driven, land-based mortalities, providing valuable insights into how wind affects seabirds, both at sea and on land, with important conservation implications for this endangered species. Mr. Vice-Chancellor and Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate.
Mr. Vice-Chancellor and Principal, I introduce to you Sibusiso. Okay. Mr. Vice-Chancellor and Principal, I introduce to you Sibusiso Samuel Mashlalela, who has complied with the requirements for the degree Doctor of Philosophy specializing in metallurgical engineering with a thesis titled Delta Ferrite in Modified 9-chrome 1-molybdenum steel weld metal, prepared under my supervision. In this thesis, Delta Ferrite in modified 9-chrome 1-molybdenum steel weld metal, the candidate examined the role of chemical composition and cooling rate on the presence of Delta Ferrite in the P91 as welded microstructure. The chemical composition was observed to have a strong influence on the presence of Delta Ferrite. A revision of a composition limits of a welding consumable specification was recommended because 65% of welds that complied with the specification contained Delta Ferrite. There were two main welding implications based on the cooling rate. Firstly, in a single-pass welding process, a slower cooling rate was observed to decrease Delta Ferrite in the as-welded microstructure. Secondly, in multi-pass welds, fast cooling rates decrease the Delta Ferrite content in the microstructure of previously deposited beads. Mr. Vice-Chancellor and Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate.
Mr. Vice-Chancellor and Principal, I introduce to you Yolandi Jooste, who has complied with the requirements for the degree Doctor of Philosophy, specializing in mining engineering, with a thesis titled A Numerical Modeling Methodology for Deep-Level Tabular Excavations using a Combined Bulking and Limit Equilibrium Constitutive Model, prepared under my supervision. In this thesis, the candidate proposes a novel time-dependent bulking model in a displacement discontinuity code to simulate the rock mass behavior. The current mine layout design criteria are based on elastic theory. This ignores rock failure and the time-dependent nature of stope convergence. This has implications for support design and for estimating remnant stresses. The thesis proposes that the time-dependent rock bulking can be expressed as a function of elastic closure. In addition, the new constitutive rule for the reef normal reaction stress is expressed as a function of the compaction strain. The remnant stresses can be more accurately simulated, while the phase fracturing can be simulated with a limit equilibrium model. This approach will improve current layout designs and mine safety. Mr. Vice-Chancellor and Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate.
Mr. Vice-Chancellor and Principal, the following candidates have complied with all the requirements for the degree Master of Engineering specializing in Chemical Engineering. William Bosch. Christopher Denton with distinction. Zander Hannibal with distinction. Eric Houghton with distinction. Bayanza Manzini with distinction. Thank you. Mpo Moeti. Gabriela Steenekamp. Brendan Trollop. Mr. Vice-Chancellor and Principal, the following candidates have complied with all the requirements for the degree Master of Engineering specializing in Mechanical Engineering. Bismarck Low with distinction. Butabu Ngwenya. Andrei Pinar. Batma Salumu with distinction. Danielle Stein with distinction. Mr. Vice-Chancellor and Principal, the following candidates have complied with all the requirements for the degree Master of Engineering specializing in Metallurgical Engineering. Johnny Mukhalanyane. Kailan Naidu with distinction. Mohammed Saluji. Mr. Vice-Chancellor and Principal, the following candidates have complied with all the requirements for the degree Master of Science in Applied Science, specializing in Chemical Technology. Monwabisi Nzimande. Hansje Rues. Mr. Vice-Chancellor and Principal, the following candidates have complied with all the requirements for the degree Bachelor of Engineering Honours, specializing in Chemical Engineering. Lesego Mofokeng. Mfundu Sibija. Lungelo Tshabetsi with distinction. Jacobus van der Walt with distinction. Mr. Vice-Chancellor and Principal, the following candidates have complied with all the requirements for the degree Bachelor of Engineering Honours, specializing in Control Engineering. Tristan Wickham. Mr. Vice-Chancellor and Principal, the following candidates have complied with all the requirements for the degree Bachelor of Engineering Honours, specializing in Environmental Engineering. Ninu Sajan with distinction. Mr. Vice-Chancellor and Principal, the following candidates have complied with all the requirements for the degree Bachelor of Engineering Honours, specializing in Mechanical Engineering. Leia Bukan. Willow Elmarie Boysen. Devon Cox. Lawrence Duplessis. Dylan Fentham. Christos Kapariliotis with distinction. Bernard Kotzenberg. Abel Courin. Dylan Loubser. Gift Lekota. Fulufelu Mashau. Shodotsu Masikwa. Prince Mbezi. Orefemetsi Mfelang. Fortune Mukone. Christian Mol. Mohammed Musa. Bradley Nast with distinction. Aimal Patel with distinction. Rotondwa Ramabulana with distinction. Cameron Turk with distinction. Damien Westley. Mr. Vice-Chancellor and Principal, the following candidates have complied with all the requirements for the degree Bachelor of Engineering Honours, specializing in Metallurgical Engineering. John Goodwin. Louis Lombard. Yashvir Mahadiu. Christoffel van Niekerk. Mr. Vice-Chancellor and Principal, the following candidates have complied with all the requirements for the degree Bachelor of Engineering Honours, specializing in Mining Engineering. Altus Bischoff. Sandile Chiluane. Nyabulu Machiani. Ndumisa Nkosi. Mr. Vice-Chancellor and Principal, the following candidates have complied with all the requirements for the degree Bachelor of Engineering Honours, specialising in Water Utilisation Engineering. Jamie Adams, with distinction. Ruvesh Bemnarayan, with distinction. Emmanuel Changane. Tafadzwa Chirinda. Kelebogele Choku, with distinction. Shlenhlanhla Komalo, with distinction. Mbongiseni Mashlangu, with distinction. Jody Smith, with distinction. Nina Swart, with distinction. Mr. Vice-Chancellor and Principal, the following candidates have complied with all the requirements for the degree Bachelor of Science Honours in Applied Science, specialising in Chemical Technology. Nonhlakanipo Mogore. Silas Timo. Karabu Molekwa. Chihamu Monyati. Ntanga Nedzeni Chikovi, with distinction. Mr. Vice-Chancellor and Principal, the following candidates have complied with all the requirements for the degree Bachelor of Science Honours in Applied Science, specialising in Environmental Technology. Ntobeku Gama. Lindelu Kumalu. Rebotile Nari, with distinction. Ntomfuti Tabeti. Mr. Vice-Chancellor and Principal, the following candidates have complied with all the requirements for the degree Bachelor of Science Honours in Applied Science, specializing in mechanics. Heinrich Enslen with distinction. James Mashal. Sammy Shika. Anna Tekiso. Mr. Vice-Chancellor and Principal, the following candidates have complied with all the requirements for the degree Bachelor of Science Honours in Applied Science, specializing in metallurgy. Itute Maroga. Shamaine Matonyane. Mr. Vice-Chancellor and Principal, the following candidates have complied with all the requirements for the degree Bachelor of Science Honours in Applied Science, specializing in water utilization. Ayanda Butalezi with distinction. Mapari Kitse. Lavelesani Luvengo. Volenda Magoloi with distinction. Claudia Mahana. Penny Mapanga. Joelu Mentor. Tamsanka Mlangeni. Silendile Mchali. Senelisu Ndebele. Nomvula Nesamari. Funani Ramalamula. Kensani Tubela. Sulami Changana with distinction. Tokozani Zungu. Mr. Vice-Chancellor and Principal, the following candidates have complied with all the requirements for the degree Bachelor of Engineering in Chemical Engineering. Richard Bester. Naisen Punu. Morisahotla Bokhosi. Hein Boonstra with distinction. Lara Buitendag. Luanda Chawane. Mia Klute. Ntedu Dlamini. Sambulo Dlamini. Sisekelo Dlamini. Sindile Fakude. Jenna Germeshuis. James Hickenbottom. Courtney Jade Houston Brown. Ruben Jacobs. Karak Jensen with distinction. Emil John with distinction. Isifu Kavi. Selaeleu Kuete. Anneke Larks. Bongani Lunga. Nokwazi Mashlangu. Benedict Malema. Tetelu Mashinyaneng. Elizabeth Mbuweni. Wandile Mchunu. Chelsea Mishlanga. Areta Makola. Lefu Mokwena. Sobokwe Mokonyane. Muketi Molai. Mandisa Mota. Anay Muller. Kiraya Naidu with distinction. Kangalani Nkabinde. Jan Willifier. Reinen Pillay. Jamie Pretorius. Tessa Pretorius. Sania Raju. Nikhil Ranjot. Philip Ruiz. Matthew Rose. Carl Schler. Zaid Sidat. Ashvika Singh. Yarik Singh. Luke Steele. Matthew Strauss with distinction. He also receives the South African Institution of Chemical Engineers Medal for the best final year student in chemical engineering and the Pro Conics Holdings Prize for the best final year research project. Molatelu Tala. Rebecca Tempest. Mogaleadi Tange. Hendrik van Buren Schelle. He also receives the Pro Conics Holdings Prize for the best final year design project. Aiden Viljoen. Ruan Versaghi. Johanna Forster. Mr. Vice-Chancellor and Principal, the following candidates have complied with all the requirements for the degree Bachelor of Engineering in Mechanical Engineering. Shagufa Abdul. Christopher Andrew with distinction. Mohammed Antulay. Stephen Archibald. Lukman Asmal. Altus Badenhorst. Janku Badenhorst. Simran Balu with distinction. Rirandu Baloy. Nkesani Baloy. Leos Bedesi. Annabelle Bester with distinction. Lloyd Beyers. Justin Bew with distinction. Johan Buitendag. Sibulele Chabalala. Dylan Koertzen. Richard Kutsie. Johan Conradi. Ryan Cox with distinction. Michael Craig with distinction. He also receives the Medal of the Engineering Council of South Africa for the best student in the final year in the School of Engineering and the Ex-Mente Technologies Prize for the final year student in Mechanical Engineering with the highest final year average. Well done. Tianu Dakoncheikau. Dakonsesau. My apologies. Angus Dalrymple Hay. Providence Danda. Martinez de Bruin. Wouter de Wet. Luke de Pree with distinction. Aiden de Tooy. Ofensi Dube. Daniel Duke. Peter Fourie with distinction. Aiden Geary. Hendrik Giesing. Davashni Govender with distinction. Lisan Govender. Nivea Govender. Pregan Govender. Preshelin Govender. Benjamin Greenwood. Jaden Ham. Brandon Harcourt. Pranav Harishan. Kyle Holloway with distinction. James Houghton. Hermanus Jacobs with distinction. Sashlin Yagdesi with distinction. Robert Jessup. Caleb Jevon. Rachel Jones with distinction. Andre Jordan. Luke Kloppers. Botang Koma. Gunther Kreur. Melissa Kreur. Bianca Legranzi. Heinrich Leroux. Louis Leroux. Lodewijk Lehman. Ryan Loubser Goldblatt. Ntiyisu Mabasa. Banele Mabuza. Tintwalu Mabuza. John McIntosh. Spesigle Madondo. Tendakai Majara. Mduduzi Magagula. Lulama Makaringe. Studuzu Manzini. Nyabulu Masilu. Shudufatsu Masindi. Musi Matabane. Yuri Matsevich. Andy Mbalati. Patrick Mbongo. Lloyd McHugh. Kelly McLean Leonard. Zander Mentz with distinction. Kevin Meyer. Tiana Meyer. Samkelu Mgodlo. Gomolemo Muchwari. Chiu Mudise. Ashlan Moshlapuli. Lindukuchle Mokwena. Barry Moody. Kotiona Mutlabi. Bawinile Mtweni. Keith Mullen. Jerushan Naidu. Lavan Naidu with distinction. Nishlan Naidu. Oshay Naidu. Sizwe Ndaba. Thank you. Lwazi Ndlovu. Hendrik Nel. Marcel Nel. Tristan Nel with distinction. Devon Nell. Nkosana Ngubeni. Tumelu Nhlapo. Johannes Nuut. Jonathan Nordingen. Nathan October. Mohammed Osman. Karabu Padi. Vincentius Palan. Annika Paul with distinction. Declan Pegg. Matthew Peterson. Brenton Pillay. David Plotz. James Pooley. Nicolas Pretorius with distinction. Wayne Prophet. Jared Pyle. Sean Papers. Marcus Rademan. Shailen Ranyeth. Matthew Reynolds with distinction. Jamie Reder. Brian Robinson with distinction. Rialdo Roelofse. Pieter Roos. Callum Ross. Michaela Rousseau. Ruben Rousseau. Gerhardus Saiman. Ralph Scherf. Ryan Scott with distinction. Pamelo Selomani with distinction. Bongisiwe Sibanda. Melvin Sitole. Fumani Siwele. Happy Skosana. Lorenzo Smargiaso. Christopher Smith. Ruben Smith. Jamie Smitsdorf. Hendrik Steenberg. Ashley Stock. Eugene Strydom with distinction. Luan Swart. Christopher Swartz with distinction. Ryan Simmons with distinction. Keenan Talyard. Angelique Tezera. Sitembisu Tukwane. Setsotu Titipana. Denzel Tivani. Ongopotsi Titi. Luke Udall. Richard Uckerman. Akil Vali. Gerard van der Bijl. Petrus van der Merwe with distinction. Hein van der Walt with distinction. Dante van der Westhuizen. Terblanche van Lille with distinction. André van Staden with distinction. Werner van Vuren. Jacobus van Wyk. Jan van Wyk. Lelandi Venter. Leo van Venter with distinction. Divan Foster. Paul Dieter Warschkool. Christian Weich. Emiel Welgemoed. Ross Wilkins. Mr. Vice-Chancellor and Principal, the following candidates have complied with all the requirements for the degree Bachelor of Engineering in Metallurgical Engineering. Latisha Dladla. Mosa Molekani. Mpu Mtombeni. Rapalang Nketia. Mr. Vice-Chancellor and Principal, the following candidates have complied with all the requirements for the degree Bachelor of Engineering in Mining Engineering, Willem Botha. Dumisani Magagula. Lesegu Mampane. Nyakalu Molaba. Rudy Phyllis. Dene Reddy. Shlompo Sekati. She also receives the medal and prize of the UP Mining Alumni Society for the Best Student in Mine Design 422 and the SA Institute of Mining and Metallurgy Achievement Award for the Best Student in the final year in Mining Engineering and the Mine Ventilation Society of South Africa Prize for the student with the highest final mark in final year Mine Ventilation Engineering. Nwengu Shilenge, she also receives the South African National Institute of Rock Engineering Prize for the student with the highest final mark in final year rock engineering. Temosu Tole.
I now request the Dean to introduce to me the candidate for the presentation of the award of the Vice-Chancellor and Principal.
Mr. Vice-Chancellor and Principal, I have the honor of introducing to you Tristan Jared Nell for the presentation of the award of the Vice-Chancellor and Principal. Tristan Jared Nell complied with all the requirements for the Bachelor of Engineering in Mechanical Engineering degree on 30 November 2024, and the degree was conferred with distinction. Tristan Jared Nell is acknowledged as the overall top achiever in the Faculty of Engineering, Built Environment and Information Technology for the year 2024. Mr. Vice-Chancellor and Principal, I request you to present the candidate with the award of the Vice-Chancellor and Principal.
I hereby I hereby present Tristan Jared Nell with the award of the Vice-Chancellor and Principal. Thank you, Mr. Dean. I think we can give a Dean a hand of applause. Well done. So I would like the audience to give our graduates for their perseverance and dedication a very warm hand of applause and congratulations. Very well done, very well done. I would like the graduates just to rise, just to stand up. Please, thank you. So now to the graduates. If you look at the platform, you see on the platform party, we have some of the academics representing the academic community in the Faculty of Engineering, Built Environment and Information Technology that has taught you, that has worked with you, that have supported you, that have transferred the technical knowledge that you would need in your different disciplines in engineering, and then probably also have walked with you the extra mile. They are the academic staff that we're all proud of as a university. Often the quality, as I said earlier in my earlier remarks, the quality of a university, an academic institution, and the reputation of the institution is often linked to the quality of the academic staff. And that is a staff that we really appreciate here at the University of Pretoria. So I would like you to put your hands together for the academic staff on the platform and the many academic staff that have assisted you during your journey here at the University of Pretoria. Thank you. You might not be aware, but we have a total of over 6,500 staff at the university. The other cohort of staff, which sometimes about 1.5% more, or not percent more, but 1.5 times more than the academic staff, is a cohort that we call support staff, professional staff, and administrative staff. They are the staff that you often don't see at ceremonies like this on the platform, but they are the staff that have made sure that we are secure where we are. They are the staff that also make sure that the campuses, the 7 campuses that we had, is clean. They are the staff that also make sure that the certificates, that your degrees and qualifications are printed on is correct. They are the staff in the registration office, the graduation office, the student affairs office. And they are often on the periphery. But I would like you to put your hands together for that staff, because they are as so important to ensure that you stand here this morning. So you can now sit, thank you. So we now have come to the end of the proceedings. Before we close, I wish to invite all present for refreshments afterwards in the marquee in front of the Rembrandt Hall. You are requested to stand for the singing of the national anthem, and to remain standing until the assembly has been dissolved and the academic procession has left the auditorium. The words of the national anthem will appear on the screens. Can I ask you to please rise? By the powers vested in me, I hereby dissolve this assembly of the University of Pretoria.
Gaudeamus